Okay, far and distance concept. So we will talk about the human eye. There's a portion about human eye also you should know. The concept of seeing things far away and the concept of seeing things close by. Imagine yourself standing on a in between two railway tracks. That's the main railway track. Okay, so that's the example given, and one of the nice example. Not that you want to leave this world just because you want to study something of science. And you know what are sleepers? Sleepers are those wooden plates which are kept. Nowadays we don't have sleepers, we have got concrete bolting. So you understand, within tracks you've got those wooden plates. All the sleepers are actually of the same length. But when you stand on a railway track, imagine you are standing in between two tracks, parallel tracks. What do you observe? As if they're going to converge right ahead. And the length of the sleepers are going on reducing one with the other. Yes or no? Yeah. So that gives us a sense that why do we see something big and why do we see something small? You see something big when the angle formed by that object is big in your eye. Okay, just remember that. I see something big when the angle formed by that object is big in my eye. In fact, this will be used a lot when you study about microscopes in grade 12. At least in CBSE, we have that in 12. It's something like this. Say, suppose this is your vision axis, and let's say this is your eye. Right? This is your eye. Now, the angle that the object will form, let's say if something is close by, when something is close by, we really see it big, right? So let's have a close by object. So let's say this is my close by object. Close by object, and I'm seeing it quite big. So in this case, if I try to trace the angle that it makes at my eye, okay, this is the angle that it is making at my eye, I will find that this angle is substantially big. This angle is known as, this angle is something like, say, this angle, in your book it is written as beta. Beta as an angle is big. Yeah. Here. And in magnifying glass, they have just explained about, you know, convex lenses, as I showed you all 5 cases. In convex lens, there's only one case where you get it magnified. In that case, we are placing the object between the focus and the optical center. As a result, you see big. Now, when this object starts shifting away, I'm saying, okay, you also should know that the human eye is also having a convex lens. But the beauty of our eye is that in our eye, we have a convex lens which is made up of a gelatinous substance. You can change the curvature of the eye, and that's called accommodation. This, again, we'll do a little bit detail because this is skipped up in this year chapter. What I mean by that is that if I want, I can increase the curvature of the eye. If I want, I can decrease. This is a decreased curvature. This is an increased curvature. Increased curvature means, in other words, you can say the eye is made up of a gelatinous substance where I can stretch the eye. Stretched. You're seeing like this. Like this means it's called stretched. We call it strained vision. This is strained vision. And when I see something far away, it's relaxed vision. Relaxed vision. The eyes are actually, the lens is absolutely in relaxed method. Okay. So when we see something far away, we see it small because the angle that that object at that time makes with my eye, the angle that that object makes is a small angle. That's why you see far off distances and things small. Now, if you see beta, beta makes a smaller angle. In the next case, let's say this is beta dash. If you see beta dash is smaller than beta. This is the concept about if it comes in a true or false question, that, you know, when you see things bigger, obviously the angle is bigger. The angle the object makes with your eye is bigger. And if you think the thing is smaller, the angle it makes with your eye is smaller. Is this much understood? Okay. So we now go and understand about some aspects related to the human eye, and where we will be talking about the human eye and the human lens. Again, a topic very much jumped in your chapter. So let me give you an idea. The human eye has got some properties. Now, this is the human eye. We can see there are 2 measurements that you should know at this stage. What are the 2 measurements? So there is something called, okay, let me erase this diagram. Have you understood this diagram? It's fine. I'll just erase this, okay? Let me, will it take or not? I don't know. Okay, this is the human eye. Now, how far can you see and how close can we see? If you are a normal person, okay, normal person with normal sight. Now, the farthest that we can see is known as infinity. The farthest that you can see is infinity. Infinity. and this of your eye is known as the far point. So if somebody asks you, what is the far point of a normal eye? The far point of a normal eye is infinity. Then there is something also which is called the near point, or near point. In other language, we call near point as the LDDV, least distance of distinct vision. Let's say this is the closest when the object is kept and I can see with my bare eyes. Are you able to understand? You have seen credit cards. Behind credit cards, don't you see, in case of loss, call the customer support 022 some numbers. So how close if I keep, I'm able to read it distinctly. So this is called the least distance. There is a word that we use for it, and the word is least distance of distinct vision. In other words, we call it, your syllabus doesn't use these words, LDDV. The LDDV for a normal human eye is 25 centimeters. Right? 25 centimeters. That means at 25 centimeters, and 25 centimeters is supposed to be when your elbow is folded and you hold anything like this. Like how do we read the mobile? We read it like this. This distance is approximately 25 centimeters. Now try to switch on your mobile if you have a mobile and see, take out your specs. Even if you are wearing specs, you take out your specs and see, are you able to read something? Like how you read a storybook. Are you straining your eyes? No. If you are not straining your eyes, that means your LDDV is correct, least distance of distinct vision. And what is your far point? Your far point is infinity. This is the behavior of a normal eye. Now in our class, we have got Dhruv who's with specs. We have got two girls out there who are with specs. I am with specs. That means there is something that is garbar with us on these, as simple as that. Now whenever there is a problem with this and this, you are going to have what is known as your eye problems. And in eye problems, we actually call it, these problems are actually called as disease. These are disease. Right? So if you have an eye problem, and issue with eye is that if your hand has a pain, then you can actually feel the pain. And when you compare it with a normal person, you say that I'm having pain, I can't lift this. So you rush to a doctor. Eyes are such a thing. What Sahasra is seeing with her eyes, I don't know. It's everything comparative. I get to know when a same color thing is shown to me and Sahasra, green, and we both have nothing. Then there is a light green shown, and I say this color is different, and this girl does not say anything. That means there is some problem with her eye. She is seeing both the colors same. That's how you check out color blindness. When children are born, some of the tests that we start doing is that we give them different colors. Are they reacting to it or not? So today, what you see from your eyes, I don't know. There are some behaviors which you will do with which makes me think that this child must be suffering with an eye disease. Say, for example, it's a classroom and she's seated on third bench. Every time I write anything on there, she gets up and keeps on asking me, sir, what did you write? What did you write? Or she has a practice to come with her copy to the board, watch, see it, and then go back. Now, this behavior everyone is not doing. She is doing. That is when somebody senior should immediately tell, get her eyes checked. There is some problem. Because what you are seeing, I don't know. And to you, you feel that the world is like this only. The very fine day when she gets her eyes checked and we give her correct glasses, she starts feeling, oh, the world is much more beautiful than what I have been seeing it till date. Are you understanding? There's a difference between eye disease and hand and body pain. Pain you can compare. You are unable to lift it, I am able to lift it. I don't know how you are seeing. And you have, whatever you see, you find that that is the accepted norm for you. This is, grass is green this much. No, maybe the grass is much more tangy green. You are unable to see. So the first disease that we talk about is a disease which the issue happens is when your far point has an issue. When the far point goes for a toss. And this is the disease which will happen in children. And all you girls and that one boy in my class, all of you are suffering from this disease, and this is called myopia, the biological name, and this is called nearsightedness. Nearsightedness. And this will be 98% of the eye disease in your age. Anyone wearing specs, myopia. Myopia means nearsightedness. You can sight the near. Please understand the English behind it. You can sight the near. Recall yourself, all you boys and girls have one problem. You can't see the blackboard properly, but you can see your textbooks properly. Whenever a cricket match is played and it shows India 314 for 8, you are unable to make out whether it is 8 or whether it is 6 without your specs. But when you read a newspaper, it's all fine. So that is called myopia. And in these cases, you will see everyone having a negative power. You can ask yourself if I'm wrong. Nidhi must be having a negative power. Ahiri has a negative power. You also have a negative power. You cannot have positive. Okay. If you have positive, I can make out right now itself. I will be able to make out whether you're positive or not without any test. It's called nearsightedness. So in nearsighted, what is happening? Let's see. So this is your eye. Okay. This is the eye. And let's say this is your eye lens. In a normal case, what we have here, this portion is known as the retina. The retina is like the film of a camera. The human eye just behaves like a camera. Camera has got a shutter cap. We have eyelids. The camera has a lens. We have a lens. The camera lens can be auto-adjusted. Our brains auto-adjust, you know. And this is known as the power of accommodation. What is power of accommodation? The power of a human being, or a human eye, due to which it is easily able to distinguish something and see something whether kept at a closer distance or at a far off distance. If you take a camera and you try focusing something far off, IPL is going on, you'll see a lot of telephoto cameras on the boundary. So what they do, the moment they start focusing on the player, the background gets blurred. Have you seen those? Those are called macro shots. So the camera will, the lens opens up. The human brain is such a supercomputer that when we try to see something far off, we don't make that V sense. We straight away shrink our eyes, and we are changing the curvature of our lens. So our lens adaptation is changing automatically. And when you bring it, look at this pen, immediately we make it like this. This is called adaptation. And in adaptation, you should be able to see as close as 25 in this. The first disease is when your far point has gone for a toss, right? So what is your far point? Your far point is no more infinity, but the far point has come closer. Try to understand. Your book has very limited written on it, but this is something interesting. Far point has come close. That's why Ahiri is able to see anything that is close. But if the thing is at a far off, our girl is not able to see. So let's first see how the normal eye will actually behave like. The normal eye behaves in this manner. The eye is a convex lens, so it's a converging lens. It should converge the image right on your retina. This is the retina. On the retina, you also have a spot which is known as the blind spot, where no image is formed. So as long as the image is formed on retina, Ahiri is able to see. Now, what is Ahiri's problem? Ahiri's problem is that her far point has come near. Far point has come closer. So jitna far point hoga, utna hi wo dekh paegi. This thing is not an issue. But her ability to see far off has gone down now. This has come closer. Why that has happened? That happens because of many things. And if we say she's having it right from childhood, that happens because her eyes are more converging. More converging means they are more golu type. Round eyes. Kajal Agarwal type eyes, dekhe, more round. Those are like more converging eyes. So what in case of Ahiri, the image formation is becoming like this. Her image is getting formed before the retina. Not only Ahiri, Nidhi, all of you. It is forming before the retina. Are you understanding? Your eye lens by default is converging more than it should converge. So you're not having any problem here. You're having problem when it is far off. So your far point has come close. So how do we cure such people? The way we will cure such people is that, now how do we cure them? Just see how we will cure them. Sorry. Let me take off this. So in order to cure them, try to understand what is the problem their eyes are doing. Their eyes are converging more. Mat karo itna, thoda diverge karna hai. So if we are giving them parallel rays, they are converging before the retina. So let's feed them little bit divergent rays. Eye will converge. So we will fool their eyes. How do you fool their eyes? Put a concave lens out here. And let's take the parallel rays. I love this topic. So what the concave lens does, it is diverted. ये तो तुम्हारा पैदाइशी गड़बड़ है, इसको मैं नहीं सुधार सकता हूं. he always adds one extra. What is 4 plus 3? He will say 8. I want to get the answer as how much? 7. So I'll say, what is 3 plus 3? Now he'll say 7. Because his addition problem I cannot solve. But if I want to hear the desired answer, let me feed the question that takes care of his problem. So now what happens? The lens is supposed to converge it, right? So it will converge. Now it will converge at the retina. Now Ahiri, Nidhi all are able to see. It's a concave mirror, concave lens. And what about a concave lens? Put your basics together. Let's see the concave lens. This is concave. Okay. What should be a concave lens? Any ray of light will diverge out. So how to get the principal focus? You will never get it on this side. You will extrapolate and the focus meets where? Here. And what is the distance on this side? Focal length, always negative. Now there is a relation. All these are not there in your Cambridge. The power of a lens, what you say, I'm -3, -2. Power of a lens is measured in a unit called diopter. Ashmita, you pay special attention. नहीं तो आपको जब optics पढ़ाएगा ना वहाँ पे power of a lens is measured in a unit called diopter. Diopter is 1 upon focal length but measured in meters. The focal length should be in meters. So if I am having high power, means my lens has low focal length. Have you understood? My lens has less focal length. Less focal length means the power will be very high. And since the focal length f is negative, so Ahiri and Nidhi and Dhruv and all of them have got negative powers. Because as kids, you will suffer from this disease called myopia. Myopia can be corrected to some extent at childhood itself if you are always very, very, what you call, disciplined with your specs. Please wear specs. Don't give up. If you are having something like 0.25, 0.2, 0.25, 0.5, those get corrected. But if you are at this age, something like say Vakul has a very high power. So if you are doing something like he's around -3, -4, something like that. So if you are having something like -3, -2.8, -3, you can only arrest it. You can only arrest it. It cannot be cured. You will carry it with you. That is surgery. You can have contact lenses also. When we put contact lenses, we are changing the curvature. And then there are some LASIK surgeries that you can do. LASIK surgeries are used for taking care of mild myopia or say astigmatism. Astigmatism, you know. Dhruv, how are you today? Dhruv, very nice t-shirt you're wearing. You feel I'm looking at whom? Sasra. But I'm actually looking at you. This is astigmatism. Looking London and talking Tokyo. Squint eyes. Squints can be, but all those are very high precision things. If you cannot do, best is wear specs. Have you understood nearsightedness? So in your book, nearsightedness is known as short sight. So this sort of person is suffering from short sight. So how is short sight rectified? Short sight is rectified by putting a proper concave lens. And this is what the trial goes on. How do you read now? How do you read now? Read, read. They go on trying. That headache because your image formation, 3 things. The pinna of your ear, there is a nerve out here which is making me stand right now. The balancing is coming due to that. Puking when you're going on hilly roads. It's everything that the image senses from here and this particular thing. Whenever there is a distortion out here, your balance is disturbed. Your balance is taken, your ears actually balance you to be on ground. Just think, all of you must have had a booster pillow you have in your bed, that long cylindrical pillow. It is much lighter than your body weight. Try to make it stand. It never stands. It falls down. You being such heavy also, if you do like this also, you're getting balanced so quickly. Look at the human body's agility to balance yourself. And this balance comes whenever there is a distortion in image formation. So what a body tries to immediately defend everything. There's a nice video about it. Our body, whenever you try to harm the body's self-defense will start activating. So body will try to reverse whatever things are there. So whatever you ate, everything it will try to reverse. Puke it out. What does your computer do? You try to go back to restore the system to a previous date. You know, in PCs, you can restore the PC to a previous date because you felt at that date my PC was good. So the body also starts restoring. Restoring is जो किया था वो सबका opposite करना शुरू करेगा वो. This is clear? Okay. Our next issue is when your least distance of distinct vision, that is your 25 centimeters, is getting affected. Okay. Now, is myopia clear? Can I rub myopia's portion? Okay. Let's see the other disease. This disease will be very rare in your age group, but not that it won't be found. If you do a research in your school, you will get at least one kid. One kid to milega hi. This is known as hypermetropia. Ashmita, take care to note down these. Hypermetropia. Hypermetropia is known as farsightedness. Just opposite of what you are. Farsightedness. This person can see the far very nicely, but he cannot see the things that are close to him. So let's see it as a disease first. This disease, if it is seen in your age group people, it will be very rare. Very rare. So let's see what happens to the eye. So this is the eye, and this is my eye lens. So in this case, it's opposite. Your eye lens are having very long curvature. They are not converging it. So the rays are getting formed where? Outside the retina. Whenever you are at 25 centimeters, your image formation is happening outside the retina. फार को देख सकते हो, फार पॉइंट पे कोई इश्यू नहीं है, नियर पॉइंट पे इश्यू है. अब समझ में आ रहा है? नियर पॉइंट पे इश्यू है. अब ऐसे आदमी कैसे देखेंगे? The way they can see is they have to stretch their arm. If you ask that person, I'll come to my age also. If you ask that person, how will he see properly? He'll say, थोड़ा दूर रखने से मेरे को दिखाई देता है. Now how far? Your arm length is maximum a meter or a 0.75 meter. After that, what do? You use selfie stick to see? Won't be able to see. So we need to give him also a proper lens. So in this case, the lens that we will give him is a convex lens we will give him. So let's see. We will put an additional convex lens out here. So again, the same story. I can't correct his issue, but I can feed in something that can correct. So what is this convex lens going to do? This convex lens is going to converge. And the role of this convex lens is also to converge. So it converges. So this will have a focal length which is positive. So the power of this lens will also be positive. Such people will be seen to wear positive power. Positive power means convex lens. Okay. If you are finding this disease in children, that is at your age group, then you won't find less power. Less नहीं मिलेगा. अगर कोई मिला ना, वो high power वाला बच्चा मिलेगा. Looking at the child, you can say he is suffering from hypermetropia. His glasses will be very thick. He doesn't have the what you call luxury to wear fiber glasses like us. Patla putla नहीं पहन सकता है. And what I am wearing is fiber. These are fiber. If you like drop them also, nothing will happen. But if you are wearing glass, nothing. Don't do that. This is costly. If you are wearing glass, then glass is very heavy. It will actually create a mark out here, but you will see they will wear glass. And since this is convex lens and the glass is very close to his eye, is also behaving as a magnifying glass for you when you are observing the boy. So you will see his eyes bigger in shape. Concave lens always makes the object's image smaller. Take out your specs, put it on the writing, use like a magnifying glass. You will see the sizes of the writing smaller. Yes. So take the lens and you can understand. Aren't you seeing it smaller? ऐसे देखो, ऐसे. Yeah, smaller दिख रहा है? Yeah. Now see with my specs, you see from the bottom portion only, right from the bottom portion. Just see from the bottom. That's a progressive lens. So see from the bottom. Isn't it bigger? See the bottom portions. Aren't they bigger? From the bottom of the lens. They're bigger? And if you see from the top, you will see smaller. That we will discuss. Then only you will get to know. Maja to isme hai na science ka. So we will give them what type of lens? We will give them positive power. And such bacha you can distinguish. These children are generally very, very good in studies. Sharp hota hai. This says there was a boy in Beta or Saishnu karke. When he was in grade 6 or something, he was much more senior to you all. When he was in grade 6, he used to do grade 12 problems. Anyone I have seen there like that. Their eyes will show much more bigger And you will see them very rare in a school. And they'll be like, yes, ma'am, I'll do that, ma'am. हमेशा आँख ऐसे ऐसे करते रहेगा. That is hypermetropia, rare at your age. Have you understood? So at childhood, what disease you can have? Either myopia or hypermetropia. Maximum chances is you will have myopia. This is very rare. Right. Now come to our case. आप उसका चश्मा लेके समझ में आ जाएगा. If you have a doubt, take a specs that will be thicker and put it on the writing. The specs will behave like magnifying glass for you. हाँ, एक होगा, एक ना एक निकलेगा स्कूल में. See, in our days, we used to have one spectacle guy in the class. That's why the word we used to use is, oh, the chashmish wala ladka, that battery wala. Now we say, two boys are there who don't wear specs. Baki sab specs man pe. Okay, right. Now let's go for one more disease. And this disease, this is not there in your book, just for your knowledge. Presbyopia. But for Ashmita, she should know. Presbyopia. What is presbyopia? Presbyopia is something which will, it will happen. It will happen. And it generally will strike from 37 to 40 years में आपको hit कर देगा. It hit me very early. I got hit in I think 37 or 37.5 years में मेरे को hit हो गया. Presbyopia. Presbyopia means this will happen to Katrina Kaif also. Everyone. Nobody can escape from it. This is aging. So when we age, what happens? The muscles that are holding what are lenses. Now, an example which vegetarians may not understand. If you are non-vegetarian, if you buy too much of an elderly chicken and you keep on boiling it in the pressure cooker, the meat will be very fibrous. It won't be that tender meat. So as you age, your meat is also not tender. So our ability to contract this particular eye lens, we lose that agility. Are you understanding? We lose that agility, and that is by 40 years we will lose that. So what happens? We have our eye lens, and the eye lenses are held by some muscles, and these muscles are known as ciliary muscles. Biology par rahe ho aaj mere sath. Ciliary muscles. So when the ciliary muscles age, these ciliary muscles do what? They either pull your lens or they relax. As a result, your lens changes its curvature. So when I've crossed 40, my ciliary muscles are not as active as you. Do you understand? As a result, I will not have issue with my fire point as long as I was normal in my childhood. And let's take my case. I never had specs in my school days. Not only school days, when I was in Pebble, I used to teach children also. I never had, I told you, till 37, I never had specs. I never had specs. That means, after that, slowly I found that when somebody gives me a pen, I'm unable to read the maker's name. And the best test is that you should take the credit card and try to read. In case of loss, which they write with very small, I'm unable to read. And I find if I'm holding it too much, then this is what she said. There is an acute pain that comes here and some puking sensation comes. As I take it far off, things become clear. So let me take off my eyes right now and let me turn on my mobile screen. So there are some messages and update. I'm unable to read anything, right? But if I take it far off, yeah, I can read Tuesday, April 15. Little bit more far off, I have no issue. So when I'm driving, I can see Bombay 400 kilometers, but I am unable to see my speedometer clearly. So this will happen to all. So presbyopia is nothing but it is similar to hypermetropia. Same symptoms. Same symptom. Hypermetropia at an age. At an age. And that's when you're first given glasses. Like right now, you're not your dad's, your moms will be the first victim now, the age where they are 40 plus, they will be the victim of this, and they'll say, hey, you have glasses? No, reading glasses. Reading glasses means they keep the glass like this, like the principal and the Munimji. So while talking, they are able to see you. I can see Ahiri, but can you, sir, sign the checks? Yes, I'm signing this. Some principal looks. I'm signing the checks, I can see from here. So there is only plus power. What power is it? Plus power. So you'll start with plus 5, plus 0.25, plus 5, plus 1, plus 1.25, 1.75. So in scales of 0.25, it goes on increasing. Have you understood? Now let's take Ahiri. Now Ahiri, when she becomes 40, she can't escape presbyopia. So we will give her plus power. But what about the negative power she is carrying from now? So Ahiri will have both problems with her. She will be having this, she can't escape, and that she is carrying on with her. So she will have a negative power. She will also have a positive power. That means she should carry two specs, one with the thread out here. So what we give her, initially, if you see your grandparents and all, they have something called a bifocal lens. Aisa rahega. How many of you have seen this type of specs? This will be typically with your bifocal. So at that time, Ahiri's negative issue is taken care here, and this is her reading. This is called accommodation power, add power, additional power. So bifocal lenses should be like this. Ahiri, next time you meet Suman uncle, okay, Sumanda, you just take his specs. He wears this bifocal. You take his specs and then you just check. So this is supposed to, it comes by your behavior habit. So when they give this specs, they say takes 10 days to adjust. Initially, you will see stairs of different shape. So the idea is when you try to see from this side, I'm seeing through negative power. And when I'm seeing down, I'm seeing through plus power. Okay. So this is there. Now what has happened? Now we have advanced a lot. Now we get lenses which are known as progressive lenses. अब यहां से हो जाता है पैसे का खेल. The one so what has happened? I have of late acquired negative power also. Age हो रहा है. Positive तो आया है. Some negative powers issues are also with me. So instead of wearing two, progressive lenses are such designed that there will be plus, 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 less, plus, minus, 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 minus. My lenses are automatically designed from plus to minus. Then there is axis plus spherical and the corridor of vision. So if you have wide corridor progressive, the lenses are around very costly. So what all type of packaging we have on lenses? First we can have water repellent, dust repellent, anti-glare, anti-scratch. Then you can have photochromic lenses. Photochromic lenses means these lenses will be with silver iodide. So when I go out in sun, my lenses automatically become like sunglasses. They become dark. And when I come inside, so that's a photo reaction. And when I come back home, they again brighten up. And then I can have wide corridor, bigger corridor. So just understand, like I do all my lens testers at home sitting in front of my monitor, because when I read the taskbar, see, I have three issues. I write, I read the taskbar, and I also see something on the toolbar of a window. One specs which should give me all correct. So the lenses become very costly. I'm getting my new specs now, maybe 2 or 3 days to come. The lenses itself cost me 7,000 because I work a lot in front of the computer. So it's anti-glare, photochromic, progressive, wide corridor. Wide corridor means you'll be able to see this side also, and no scratch, no dust, nothing will come, and fiber. Frame cost is hardly 1,500. Lens cost is 7,000. So that comes progressive. After this, when you come to 50, that is what now I'm afraid of. From 50 onwards, another sword will be hanging on your eyes, that is cataract. What is cataract? Cataract is the form of a cloudy layer formation in front of your eyes. As a result, your vision will be highly impacted. You will see everything unclear. Like my mom has got cataract surgery done. Earlier, cataract surgery was something huge issue. Now they do cataract surgery like chicken dressing. It's hardly a 15 minutes job for one person. And in one day, they will make people sit like chickens. Yes, next, next. So so cataract surgery. So your eye will be continuously flushed, and your relatives can see your eye surgery video. They enjoy it. So the video photograph, if you want, you can watch that. So that is continuously flushed. So there will be a small what you call laser scalpel which will take clear of the cloud. The cloud means it is something like, have you peeled boiled eggs? Sometimes you get a very thin membrane with a boiled egg, which unless you remove the egg is very rough. Once it gets removed, the egg smooth surface comes out. So like that membrane, the cloud will be cleared. And then it comes as a package where in your eye, now this is your eye. Now depending upon your expense, ability and all, they will place a permanent lens. These sort of lenses are called IOL, intraocular foldable lens. This lens will be fitted permanently on your eye. And there are various cost packages. It is assumed that you should not use specs after this at all. But if you want to have that lens, the cost of the lens is very high. So people usually will do these surgeries generally at 60, 65. Harsh to say, but then people take a call on Remaining life versus the call comes, will you be a student? No. What do you want? Let's say my mother, both eyes are done. So what is her demand? She should be able to read. She should be able to watch TV and comfortably. So when I went for her surgery, that would be when we did in Hyderabad, that would at least 7 years or something has gone, 7-8 years. So her surgery lens packages in those days were 45,000 or 50,000. 45 one eye. Those days, if you don't want specs, it was costing something like 90,000 or something. These are covered by insurances, also cover it. So 45,000. But you will have a light specs will be there. These specs are supposed to be used when you read something. So throughout the life, that lady has used specs. Even if I ask her, you don't need specs, psychologically she will not agree. She will say, nahi, chashma to chahiye. So till the day your last day on this planet, the lenses are a part of your body and they go along with your body. That will happen to everyone. So a lot of NGOs, they do in villages drive, they put these lenses. Those lenses are cheap, but in a case, at least it is giving you vision. But yes, once a person has done his or her cataract surgery, vision is absolutely like a kindergarten boy, clear ekdam. Naya gaadi kharide hain, new car, headlamps are absolutely white. As the car goes 7-8 years older, the headlamps start becoming what? Yellowish. So as I'm aging, I'm now 47. My headlamps are now no more that white, they're yellow. 100% I'm not seeing the earth as beautiful as you all are seeing at your 14 or 15 years of life. Has to be. And somebody who has not done his cataract surgery. So nowadays cataract surgeries are even getting reported at 53. My only fear part is I have heard there is no pain. But just imagine somebody doing something on your eye. Actually, there is a device which they put on the eye and the eye stretches out in this manner. And then continuous flushing goes on. You'll feel a lot of water is coming, but tools are inserted in your eye. But there's no pain. I have not seen anybody shouting, crying. Only that 3-4 days you can't take bath means water should not fall. You can't see too much of glare. And then you're fine. Black glasses when you go for too much of exposure to things. Or they will also put green color eye cap on you, like half of an eggshell type of thing will be put on your eye. Is it clear? Your book only says about shot, but I thought that you should have a good idea about what specs, who is wearing what. So these are progressive lines. That's why you saw this one. So how do you understand? Take anybody's specs and try to read here. So if you see the image is bigger, that means he's wearing a plus power. If you see smaller, he's wearing minus power. So this much is done. I think you need to know only hypermetropia and myopia. So presbyopia is a symptom which will happen. Presbyopia is not a disease. Myopia and hypermetropia are disease. Presbyopia, no one can escape. All of us will have it. So nowadays you'll see people recent in their 41 and 42. If you take a bank check or something to sign, they will very nicely first pick out their specs. Kidhar hai dikhao? They'll put on their specs and they'll see. They are the new entrants to that club. Okay? Our next topic is dispersion. Dispersion. So what is dispersion? Splitting of white light into its constituent 7 segments or 7 fragments is called dispersion. So we have white light. White light. So what are the 3 characteristics of light? A light as a wave should have speed. A light as a wave should have a wavelength, because we are studying waves. And a light as a wave should also have something called a frequency. Yes or no? Okay. We are not bothered about frequency because frequency does not change as long as the source does not change. So light is coming. So we are bothered about wavelength. Wavelength is something that will actually decide the color. So if you see different colors, they are because of different wavelengths. Okay. Now, if I see light, then light comes from the EMS, electromagnetic spectrum. And obviously, I'm not going to write the whole spectrum, but I'm just writing, say, this is ultraviolet. So starts from here, VIBGYOR. And this is infrared. Understood, children? Before ultraviolet, we will have X-rays, gamma rays, infrared, then we will have microwave and radio waves. So if we look at frequency, if you look at frequency, then the frequency as you go from left to right, the frequency reduces. More is the frequency, more is the energy. Gamma rays have very high frequency. So what do we have here? We have X-rays out here and we have gamma rays out here. You have got microwaves out here and you have got radio waves. So radio waves, the frequency is less. That's why these are all cancerous. They can penetrate your body. ये सब cancer zone है पूरा. Okay. And when we talk about wavelength, the wavelength always increases on the right hand side. Right? A device through which we can actually split up is known as a prism. So I'll do a proper diagram, then it will be easy for you to understand. Okay. Let's take a proper diagram. Okay. So let's see what happens in a prism. This is a triangular prism. Right. So white light will be incident on this prism. Let's take our white light. Let's take a ray of white light out here. Okay. Now what is happening? This is air and this is glass. So we have refraction to take place. So how does refraction take place? Draw your diagram. Try to bring the normal. First we'll bring the normal out here. Again, Ashmita, all these are very important for you, huh? This is the normal. Yes. This is the normal. Now try to imagine. Light is entering from air to glass, rarer to denser, khula khula to nirbhar bus. So light's energy speed will fall and light will bend towards the normal. So let us bend light towards the normal. Okay. So light bends towards the normal. So light bends towards the normal. All right. If you have slightest doubt, this is a rarer medium, children. This is a denser medium. And again, you are coming out to rarer. All right. So I should have my second normal. That is the second point of refraction now. So my second normal is normal out here. Did you get it? Now, light is entering from denser to rarer. So what happens to light? Light bends away from normal. Yes, see, it's so clear now with your concept. Light bends away. So light has bent away. Do you see this? Yeah. Light has bent away. So if we actually compare it with the glass slab, I hope you remember the glass slab experiment. In glass slab, shall I just draw the glass slab figure parallelly? I'll draw a rough hand diagram, okay? So that you just understand the glass slab. This is a glass slab. A ray of light comes in this manner. So this is the normal. It bends towards the normal, and then the next, and again bends away. The incident ray and the emergent ray will always be parallel in a glass slab. They're always parallel. And the distance that this ray has moved, this particular distance, this is known as the parallel shift, or we call it the lateral shift, if you remember. Ray ऐसे आ रहा था, ray छटक गया थोड़ा सा. That was what in your question I used to say, that the pin experiment. If you take a glass slab like this and you put a pin and you see through the glass slab, you will think you are seeing the pin, but you will be actually pinning it somewhere. Let's slide away, which actually shows that the emergent ray is parallel to the incident ray. There is a parallel shift. But out here, if you say, there is nothing called parallel. Okay, if I say this was say OA, then A to B and B to C. Now OA is never parallel to BC. So in this case, what we do, in this case, we will be bringing up what is known as, this ray of light was supposed to go in this direction. Do you agree? And if I extrapolate this ray, then this ray of light is going in this direction. So this is known as delta in higher classes, which is my angle of deviation. This much my light ray has deviated. Do you get it? Now one more interesting thing. Let's see here. Okay. Let's see that interesting part. Let's see here. Do you remember the convex lens? How the diagram used to be? A ray of light used to go here and used to come this side. A ray of light used to come here and go this side. Now look here. The convex lens was nothing but a combination of various prisms cut across. Oh. For this prism, niche. For this prism, it's an ulta prism. Aise. So that's how that analogy is given. Did you understand? The convex lens is also a lot of prisms together. Now, the discussion that comes here is that this is the actual drawing, but in reality, I'm going to have many colors. So the first ray that I'm going to have, it is the pattern of Vibgyor now written in reverse order. Okay. So violet, and then you say indigo. I don't have so many color options, so you can make your diagram. So it's like this. It starts from ulta hoga, VIBGYOR. So violet will undergo the maximum deviation, red will undergo the minimum deviation. Are you understanding? I wrote red here, but everything will be in this spectrum. Violet, indigo, blue, orange, yellow, red. But there won't be any clear distinction. Like in a band of how you see rainbow. In rainbow also you see all colors. You won't see a crystal clear demarcation, but the colors slowly shifting. So violet, if you look at violet, violet has the maximum frequency, minimum wavelength, because the wavelength is increasing in this order. Red has the maximum wavelength. So the one with the maximum frequency and the lowest wavelength is deviated maximum. That is also one of the reasons that all the danger signs and every back lamp of car and everything are red. Red undergoes minimum deviation. दूर से दिखेगा आपको. Red का scattering भी कम होता है. Blue scattering is very high. The sky becomes blue because you'll read it later on that the blue light is scattered maximum by the atmosphere. Red is not scattered. That's why on a foggy night, if a railway engine driver is driving his railway wagon, and a red light has been focused on him from far off, he will see it distinctly. Red को आप मिस ही नहीं कर सकते. A small dot of red can be visible from far away because red does not undergo scattering. Red's deviation is minimum. So this is all about dispersion of light. What is dispersion? The phenomenon by which a beam of white light can be broken into its fragment of 7 components, VIBGYOR, in the order that violet is deviated maximum and red least. One of the devices that can help us show dispersion is a prism. If you bring an identical prism and you just fit it, how? You just fit it opposite to it, such that they form a parallelogram. These all scattered will again combine and form white light. You know the Newton's wheel? Newton's wheel, you can make a wheel of these 7 colors as concentric circles and then spin the wheel. What is the color you will see? White. And the basic colors also, if you are into say fashion designing or 3D printing or photo printing, poster making, they'll always say, what model are you working on? Your printer works on RGB model, red, green, blue, or does it work on the CMY model, cyan, magenta, yellow? These are the 3 basic colors with which every color you will be able to make. Like when I was doing sometimes a vector printing, and then the designer studio said, sir, get us the CMY print of this diagram, of this design that you want. CMY means cyan, magenta, yellow. Mix them. Have you seen how paint colors are selected? Sometimes go to a paint shop. Very nice. You suppose you will get a Asian Paints catalog which will have so many colors. Pastel green, yellow green, peacock green, my love green, this green. So what they do? There is only a base that you purchase. The bases can be either Royal, depending on how good quality you want. Like this is washable. So Royal base will be costly. Or you can have an Apcolite or something, Tractor, whose base is, you can have the same color even in cheap quality also. The only thing is that the base will. So bases are available. Shop does not keep all the colors. How can shop keep so many colors? In shop, the color that comes is a base white color. And then you tell them 7226, morning mist yellow. So they'll have one computer, one Takahara computer and machine. So they will put your white colored, what you call that particular dabba. Sir, kitna chahiye? 1 liter. So they'll open 1 liter white. Confirm, sir, confirm, because after that, no reversal. Now they will just put it under that machine, just like you put your cup below a cappuccino or a mochaccino, that coffee machine, the way you put it. And then he will enter. Everyone has their software. Asian Paints will have a software. He'll enter 76. Sir, confirm na 76. 7626. And then you'll see there will be 3 jets. Cheap, 1 color, a 2nd color, 3rd color. Those colors will be injected. And then he'll close it. And then he'll switch on the machine. It will make it tight. And then that machine will go on tumbling this way, that way for 1 minute or so. After that, when he opens the dabba, it's exactly that color. And the best part is, you fall short painting your room and you need more color. You go to him and again tell that, you'll again get the same color. There won't be any patch difference. Initially, when you paint, you'll see patch. As it dries, the patch goes away. Understood? That's how I showed you that AC hole. You remember how I had painted? So that painting was done long later, but that you can't see the difference. Clear? Dispersion of light. So dispersion of light means the phenomenon in which light is broken into 7 segments. So that's dispersion of light. And after that, we have one thing, monochromatic light. Light of one color and one frequency is known as monochromatic light. Monochromatic. Then you will also hear about polarized light in one frame. So this is what we have. Let's see one exam type question. You can yourself also attempt these questions. These are very easy. Just remember, whenever you are working with prism, it's the concept of rarer to denser. This actually makes us finish this unit of light. And what I'll do after this is, since I have not taught you, I'll be going with 3.3, which is the electromagnetic spectrum, which you did with your first term exams. This is a very easy chapter. Have you done electromagnetic spectrum? You have not done. Yeah. Have you read about like gamma rays, X-rays? This is theory chapter. Not magnetism, spectrum. It's of waves only. So we'll do this. This is very easy. It only tells you what are what rays, how harmful it is and how beneficial it is, what are the uses, nothing more than that. So maybe in 1 or 2 classes, we'll be able to finish electromagnetic spectrum. And once we finish electromagnetic spectrum, then we enter sound. So we will do sound. That makes us complete waves. Now,